Hello, welcome to AWS Supports You. I'm Gaurav, a technical account manager based out of Delhi, India. We are happy to bring you yet another episode focusing on observability. On this show, AWS support experts provide tips to optimize performance in the cloud, lower costs, and share with you the best practice and design considerations. Joining me today are Arun and Siddharth. Can you give us a quick introduction, Arun, followed by Siddharth?
Hey, thanks, Gaurav. Hey, welcome everyone to the series AWS Supports You. I'm Arun. I'm part of the AWS Solution Architecture team, working with AWS for 3.5 years now, and I specialized in database and observability solutions.
Thank you, Gaurav. Thank you for hosting us today. I'm Siddharth Joshi. I'm Technical Account Manager working with ISV customers, and I'm a SME in observability. Thank you.
Thank you, Arun, Siddharth. So today we'll be introducing you to getting started with OpenTelemetry and ADOT. The presenters will be specifically focusing on the use of ADOT and as to how it can be used to build a better observability solution. But before we get into the details, a quick note to our attendees online. Please feel free to use the chat window on the right hand side of your screen to let us know where you are joining us from. Please also do share your thoughts and questions throughout the episode. We look forward to hearing from you. We'll also provide a link to our survey, so if you would like to let us know on how we did, do click the link and leave your valuable feedback. So without further delay, I'll hand it over to Arun. Arun, can you please walk us through what we are going to be talking about today?
Sure. Thanks, Gaurav. So this is our agenda for today, and a packed agenda for next 1 hour. And since this is an observability talk, we will talk about observability, and we'll do a little bit of level setting and understand what are the key pillars of observability, and then we'll talk about what OpenTelemetry is and what is this project about, and some of its component and architecture and how it works. And then in the later part of this talk, we will talk about what is AWS contribution in OpenTelemetry, what is AWS Distro for OpenTelemetry. And at the end, Siddharth will also show us a demo how you can instrument telemetry data from EKS using ADOT. So let's get started. So since this is an observability talk, let's first do a little bit of level setting and understand what observability is. Now, earlier we used to call it monitoring, and monitoring is essentially about like a green light, red light. It tells us if the system is working or if the system is not working. Versus, and it monitoring is also about like good mean time to detect, good coverage, and good signal to noise ratio. Versus observability is it's more about why. It's about if the things are not working, why they are not working. It's also about being little proactive because now we run larger scale applications and we can't afford to run blind. So we really need the system which can give us depth of information. When we talk about observability, we basically look at detect, investigate, and remediate. So we detect, we mean that we need capabilities to quickly detect the issue. And with investigate, customer says that it is a phase where a lot of time goes in because to investigate, we really need to rely upon a lot of data coming from various sources. So we need a system which can really help us cut through the chaos and help us focus what really matters. And then when we are in the middle of the issue, we give it a fix and we remediate that. We initially give it a temporary fix, and then we also want to make sure that we identify the issue completely, and then we give it a permanent solution to ensure that it will not happen again. And which is where we need to rely upon a lot of data, and we need a system which can really help us correlate information that comes from various different sources. Now let's look at what are the different pillars of observability. So observability essentially, when we talk about observability, we talk about three key pillars, which is metrics, logs, and traces. And there are fleet of services to process this data. Within AWS, we have CloudWatch, we have OpenSearch, and X-Ray. Now let's look at individually what are they. So metrics is, and the simplest example for metric is CPU. So it's a numeric value. It is a time series data that has sample value point recorded against a particular measurement over a period of time. For example, CPU, you can plot it over the period of time, and then you can analyze the performance. Then we have logs, which is a timestamp data, and log again can be structured or unstructured. Essentially, it talks about an application behavior or at any given point in time. So we use logs to find out how application was performing at any particular point in time. And then we have traces. And traces is more user centric, or it gives a lot of information how user is traversing through different microservices. Now, traces are very important and interesting piece of signal, and particularly we talk about microservice architecture, because trace provide details about how user is traversing through multiple applications and microservices as he's processing through the application workflow. And now to process this lot of telemetry data, which is metrics, logs, and trace, we have fleet of services. So on my left, we have CloudWatch related services. And again, CloudWatch is a battle tested tool. It is deeply integrated with AWS services. And it's good for customers who are completely on AWS and need an observability solution, which gives a wider coverage and it's deeply integrated. At the other hand, like on the right hand side, we have open source managed services, and we have a fleet of services, like we have Amazon managed Grafana, Amazon managed Prometheus, and at an instrumentation layer we have ADOT, which we will focus today. Essentially, it is good for the customer who have open source first strategy, or customer who want to give a seamless experience, monitoring experience on prem as well as on the cloud. So now let's look at what OpenTelemetry is. So OpenTelemetry is a CNCF project. It gives us a standardization layer which works between the application and your observability analysis backend. And it allows the developer to seamlessly instrument the telemetry data from the application. It supports various programming languages, as you see on the screen. So regardless where the developer is building the application, be it C++, .NET, Go, uh, developer will be able to use a standardized set of SDKs and APIs to generate or instrument the telemetry data. Another good part is it also integrates with libraries. So imagine you have a database driver and you don't want to modify your database driver to track your query or generate or instrument the query set. You and that's the case with most libraries. With OTel, you can do that, and OTel supports that, which means you can just plug it and enable it in your application and directly generate the trace data from your application. Now, with that, let's also look at essentially what use case OTel solves, or what challenge OTel solves. So now when we talk about distributed applications and microservice architecture, we see that developers are developing and using different SDKs. Now, while instrumenting the telemetry data, different SDKs have their own format, and the telemetry's data is generated in different format, which requires a specific agent to process that information. Now, with that, we have challenges in correlating that information because there are different formats, and we lose also a lot of contextual information. This is where OpenTelemetry or OTel project help. It gives us a single solution which is vendor agnostic. It gives us the capability to process data from and take data from multiple sources and move data to multiple targets. And essentially, we'll look at it today as we build the talk. Now, we also need to understand what that OTel does not give us any persistent layer. So it is not an analysis backend. So to analyze your telemetry data, you need to rely upon another backend tool like CloudWatch or Prometheus. Now, with that, let's take if there are any questions. Gaurav?
Right. So, Arun, I do not have any questions from the audience at this stage. I would like to remind the audience to please use the chat option on the right-hand side. If they have any questions for our speakers, we can ask them live during the show, and then take them forward. Actually, as I was talking, there is a question that just popped up. This is by user G Garima 7. And the question is there any cost for using ADOT solution?
Yeah, so that's a good question. So there is no cost for using ADOT. It's completely open source, and it is free for our customers.
All right. So yeah, back to you.
Awesome. So then let's move. Let's understand what is telemetry signal. So, and I thought I'll emphasize this because we'll use this term telemetry signal time and again as we build the conversation. So, when we receive data, a metric data or log data or traces, we call it telemetry signal. And you will see this term telemetry signal being used multiple times, when you use OTel or ADOT. Now the next is, and let's understand like how the architecture would look like for your observability solution without OTel and with OTel. So the first is how currently you build an observability solution without OTel. So you have the developer build the application in different languages, and they use different SDKs. And then since the data is generated in different format, it is processed by different agents. Now the different agents will then send this data to different backend targets. So you will have different targets for metrics and for traces and for logs. Now this is where you lose a lot of the contextual information, and also a lot of challenges that you will have in correlating that information. Now, with OTel, essentially we replace the different SDKs with a single OTel collector. So you will have one OTel collector. It could be an OTel collector or ADOT, which we will cover. It sits between your application and your backend uh, um, analysis backend, and it gives us a single library which is vendor agnostics. It uses one protocol, and it basically allows us to receive data from multiple sources and process that data. So we can either filter it or we can do some batching, and then it allows us to send data to different targets. Now the benefit of that is, once your application is configured to instrument the telemetry data, developer can anytime change the target without changing the instrumentation layer. Now let's look at the different components of OTel. So primarily there are four components, which is specification, uh, OTel collector, SDK, and then instrumentation and contract packages. And I will not emphasize more on specification. There is a GitHub page which talks about different specifications, or you can say uh, standards for building an application compatible to OpenTelemetry. So you can check out the GitHub page if you want more details on a specification. Now let's talk about OTel collector. Now, as I mentioned, OTel collector is as a standardization layer which sits in between your application and your analysis backend. It provides us a vendor agnostic, standardized way to process telemetry data, and it supports various formats. So it supports OTLP, Jaeger, or Prometheus. There are different other commercial observability tool providers also now they support OTel. So OTel gives various receivers for allowing you to receive telemetry data from various sources. If you talk about OTel collector components, there are essentially four components, which is receiver, processor, exporter, and extensions. So as I mentioned, it allows us to receive information from various sources. So we have different types of receivers like Prometheus, X-Ray, Zepkin, and OpenTelemetry. Then it gives us different processors. So we have different processors, like we can do processing of the telemetry data as we receive the signal. So we have different processors, but just for example, we have a batch processor which can do batching if you want to batch the signals before you send it to the target, or we can have a filter processor where you can filter the data before you send it to the target. Then there are different exporters, like we have, you can send the telemetry data to different targets, like you can send it to Prometheus or CloudWatch. So for each target you have different exporters. And then we have different extensions. So we have like a health check extension which gives you a health check endpoint, which you can utilize to find out if the collector is working or not. And then we have SigV4 extension, which is for authentication, which Siddharth will talk about. Now, at a very high level, when we talk about the configuration, this is a sample configuration file to configure the OTel collector. And I thought to bring it up so you understand how flexible it is to configure hotel collector. So in the first section, you see we can configure the receiver, the processor, exporter, and extensions. And we can configure, let's say for processor, if you're using a batch processor, we can define like what is the batching time, how in what interval we want to batch the signals. And then in this later part of the configuration, we define service, where we can define what processor or receiver or exporter we are going to use for trace, metrics, and logs. Now, this also tells us that it is very flexible. You can have different receiver and exporter for trace data, for metrics data, and for logs data. Now, to move the telemetry data to the hotel collector or to your processing analysis backend, you need to instrument your application to generate the telemetry data. And for instrumentation, essentially there can be an auto instrumentation or manual instrumentation. So auto instrumentation means that you can just instrument your application by using the SDKs with very minimum change in the code or no changes in the code. And then you also have an option where you can manually instrument. And again, I just thought of like plotting it against the effort and reward. So if you do the manual instrumentation, you will have more granular control. So you will put more efforts, but then you will have more reward because you will exactly instrument the metric that you need to monitor your application based on your use case. Now let's look at how hotel works and a very high level flow, how you can process your data and create an observability solution using hotel. So at a very high level, so let's assume you have an application code which is running on EC2 or on container. The first step is basically is to instrument the telemetry data. Now you can instrument the telemetry data by using auto instrumentation layer. And there are different APIs and SDKs which are available for you to instrument the data. Then you will have your OpenTelemetry extension and processing layer, where you can do the processing before you generate or you move the telemetry data to the collector. And then you have in-process exporter, which again will allow you to define the format before it sends. Now, at a very high level, there are two ways you can move the telemetry data. One, that from the application instrumentation layer, you can directly send that to the monitoring service. Second could be that you send that to the hotel collector, and then hotel collector will then send that to the monitoring service. There could be a third way, which is your application directly sending that to the hotel collector or to the application monitoring service, which may not be a very good architecture. Ideally, you should instrument your telemetry data, send that to the hotel collector, and then hotel collector should be utilized to send the data to the monitoring services. Now let's break for Q&A and see if there are any questions.
Yes. So Arun, we have a couple of questions. There was a follow-up from G Garima 7 asking us if they can switch from CloudWatch to ADOT that they're currently using.
Yes, so I think there's no need to switch from CloudWatch to ADOT. If you're using CloudWatch, you can continue to use it because CloudWatch allows you to monitor your logs or capture your logs and your infrastructure metrics. But you can also at the same time use ADOT to capture application metrics and trace data.
Okay. All right. And the next one is by user YUSADOLAT001. And they're asking if there is any relationship between ADOT and X-ray.
Gaurav, we can take this question at the end when we will cover the X-ray exporter.
Yeah.
Sure. Okay. And finally, I have one more query from D Kumar 707 asking if they can collect only the metrics and disable the tracing while using ADOT.
Yes. So like I showed the configuration file, it's very flexible. So it's up to you what you want to capture. You want to capture metric data only or trace data or one of them. and then it's very flexible. You can also have metric data being captured by different receiver and exporter, and trace data being captured by different receiver and exporter. It's very flexible in the configuration part.
All right. We have one more question coming in. This is from Mukul Srivastava asking, apart from application monitoring, can we use OpenTelemetry for infrastructure monitoring as well?
Absolutely. So I think that's what we have a demo today. We'll show you how you can use hotel collector with EKS and collect a lot of infrastructure metrics and convert that into a good dashboard.
All right. So these were the questions that I could see in the chat for now. Again, team, feel free to keep the questions coming. We'll try to bring them up in the next available Q&A. Back to you, Siddharth.
Thanks, Gaurav. Thanks, Arun. So far we have talked about the basic building blocks of observability, the challenges, and how OpenTelemetry helps to address those challenges. Now let's talk about AWS Distro for OpenTelemetry and what is AWS contribution to this ecosystem. So AWS Distro for OpenTelemetry is an open source distribution. All the enhancement which AWS brings to OpenTelemetry are all done the upstream. We are not going to fork this project. It will always remain the distribution. We While we build ADOT, we make sure that all the components which we take from upstream are ready for production, are well tested and validated for performance and security, and AWS support is ready to support that. Also, the hotel project is very popular. There are a lot of contributions coming. So we have a release cycle. So every 90 days, we take the code from the upstream and build the ADOT. Using ADOT, we can collect the traces, matrices. We can correlate that. We can add contextual information about the AWS resources on which our workload is running. And then we can export those to AWS X-Ray, CloudWatch, Amazon Managed Prometheus, or if we choose to go with any third-party monitoring solutions, we can do that. Now, what are the benefits of using ADOT? That we talked about that ADOT is the upstream first. So let's understand why upstream first is important. Because first of all, upstream first is the good open source citizenship. And secondly, it gives us an opportunity to vet any idea which we have, to vet it with a larger community, right? And specifically when the ideas are conflicting with each other. In such scenarios, it is always the community interest which wins, and in turn it helps our customers. We also make sure that all the ADOT component which we take have gone through our AppSec process. So it gives you the same security which our AWS services on the cloud gives you, and it has the same predictability. Uh, because it is open source, and one of the challenge open source software can face is that it's very difficult to troubleshoot if we do not know in depth. So we have always AWS support to help you, and customers who are using enterprise support can contact their TAM or their SA to get the further specialist engagement. They can get the architectural guidance and uh, any queries which they have regarding their observability strategy, specifically around open source. And we provide one-click deployment for AWS services like Lambda, ECS, even EKS. We have ADOT operator. It is very easy to install. The exporters are available for AWS solutions, monitoring solutions, as well as any third-party monitoring solutions. So let's look at some of the use cases. So at first, there are customers who are looking to have a standard for their observability strategy across their applications. So those are the customers who would look for the ADOT because it provides them tools and mechanisms to do that. Then there are customers who want to remove the dependency on their observability vendors. They want to go with the manually instrumenting their application using OpenTelemetry, and then it definitely going to take them more time to build and instrument all of their application. But once they have done it, it makes their application independent of observability vendors, and ADOT provides those tools, and OpenTelemetry provides those SDK to achieve this goal. And also OpenTelemetry is a large ecosystem. So we have a lot of agents and instrumentation libraries are already available. which customer can utilize. For example, if you are running a Node.js application which is communicating with Redis, you do not need to write any code to instrument that because there are already packages available for it. Now, let's look at some of the components which we have in ADOT. The upstream OpenTelemetry repo has lot many, but what the components which we take from upstream are only the ones which are mature or close to being matured and have gone through our AppSec process. So still we have wide variety of receivers, processor, exporters, and extensions. So let's look at an example that where we want to receive the matrices in the Prometheus format, and then we want to export those matrices to Amazon managed service for Prometheus. This is an example which we will see in the demo later today as well. So using Prometheus receiver, we will receive the matrices. We can apply processors like batch processor, which Arun talked about. There are other processes like matrix transform processor, where we can add certain attributes to matrices, and filter processes processor, where we can drop certain matrices. And then there is an exporter, Prometheus remote write exporter, and there is a extension SIG-v4, which provides us the authentication. If you have not heard of SIG before, Signal version 4 is basically an authentication mechanism for signing the request which you send to AWS APIs. And let's look at another example where we have an application which is instrumented using OpenTelemetry SDK and want to export the traces to AWS X-Ray. So I think there was one question came that what is the relationship between X-Ray and ADOT? So ADOT is where we are collecting the traces, and X-Ray is where we are going to analyze those traces. So this is another example which we are going to see in the demo later today. So using OTLP receiver, we receive the traces. We can apply processors like attribute processor, span processor, and then using AWS X-ray exporter, we are going to export those traces to AWS X-ray service, which we can use to analyze it further. Now, let's look at the Prometheus receiver and Prometheus remote write exporter of the ADOT. So Prometheus receiver gives us the compatibility with Prometheus, right? So it has the capability to scrap the metrics in the same way which Prometheus server does. It can also do the service discovery and metrics relabeling, right? But what it does not have is that it does not have a storage like Prometheus server does, right? So it needs a place to send those matrices somewhere. So it can be a storage like Cortex. So a short note on Cortex that Prometheus is a great tool for metrics monitoring, but there are challenges in scaling it. So there are two popular CNCF projects which provide scalable storage solution for Prometheus, Thanos and Cortex. So using Cortex, AWS has built a managed Prometheus service. We call it Amazon Managed Prometheus service, and we can use that as a storage for our matrices which are collected by a Prometheus receiver of ADOT. So this is how the high level uh, flow look like. So we have ADOT collector pipeline in which we have defined a Prometheus receiver. That Prometheus receiver is scraping metrics from the application metrics from application, infrastructure metrics from Kubernetes, and then we can define the processors which we want in this particular pipeline. We can relabel the matrices, or we can drop some of the matrices, and using Prometheus remote write exporter, we are going to export those matrices to AWS managed Prometheus service. And then we have managed Grafana service, which we can use to create beautiful dashboards using the metrics data which is available in Prometheus service, AMP. So this is how, now if you look at the remote write exporter part, the exporter part of our pipeline. So we, in exporter, we define an endpoint, a remote write endpoint. This is the endpoint of our Amazon managed Prometheus workspace. So this is where we are going to store the matrices which we are scraping through our receiver. And the SIG-v4 authentication extension is going to help us authenticate our request to the service. Let's look at some of the deployment method of ADOT in EKS. So first of all, we have the simplest ways we can run it as the simple Kubernetes deployment. That is the simplest way to run it. And then there is a daemon set. In daemon set, we will have one instance of our ADOT running on each of the node, and uh, we can go with this pattern if we want to evenly distribute load across all the Kubernetes nodes which we have. Then there is a stateful set pattern where we will have predictable naming for our ADOT collector instances. If we have an automation where we requires the uh, standard naming, right? Predictable naming convention, then we can go with this. And then there is a sidecar deployment. In sidecar deployment, ADOT run with in the same port where our application is running. It is again the simple, very simple to deploy. There is no service discovery required because there is only one service which ADOT is talking to. And then it is fastest way to upload data from application. But again, the drawback of this approach is that if you're going to make any changes to ADOT collector, then you need to redeploy the application as well. Uh, so we have ADOT operator as well. So ADOT operator is a Kubernetes operator. It's a what it does. It gives you capability to manage the OpenTelemetry collector in the same way when you manage the Kubernetes native objects. It basically extends the Kubernetes. And in EKS, we have single click deployment of ADOT either through the console or through CLI. So if we install the ADOT add-on for EKS, so that is how it looks like. So once we have installed it, then a pod of ADOT operator will start running, which will talk to Kubernetes API server. And when we deploy an object with resource type OpenTelemetry collector, then our Kubernetes API server will notify our ADOT. ADOT will read the custom configuration which we have provided in our file and going to deploy ADOT collector based on the configuration which we have provided. We will see this in demo today. So now what we are going to see in demo, there are sample pipeline configuration which I would like to show you. This is repeated, but we are showing it to make sure that everyone understand that how a pipeline looks like and how easy it is to configure it, right? So we have a receiver where we have a Prometheus receiver, and we have defined the configuration for it and the scrap jobs like we defined for a Prometheus server. Below that, there is extension SIG-v4, which helps you to authenticate ADOT request with our AWS services. On the right side, we are using a batch processor. We are batching metrics every 60 seconds, and we have defined an exporter, which will use the remote write endpoint of our Amazon managed Prometheus workspace and will export it. So under services, we create a pipeline for metrics. So what we are saying is that we are going to receive metrics on this receiver, we are going to process it using this processor, and we are going to export it using this exporter. So now we can define multiple receivers, multiple processors and exporters, and using those combinations we can create pipelines. This is how the configuration look like for X-ray. So we have a receiver, OTLP receiver. So we are going to receive traces on this receiver because we have defined under pipeline that we are going to use this receiver for traces. We are not using any processors for this pipeline, and then we are going to use AWS X-ray exporter to export the traces which are received to AWS X-ray service. So I think at this stage we can, before we dive into the demo, I think we can stop for taking questions.
All right. Um, so I would like to again remind our audience who's watching the show live to please use the chat option to ask any queries that they have, which we can bring forth to our presenters live in the show. So having said that, while the questions are coming in, I had a question that came to my mind while you were talking about ADOT and EKS. Siddharth, can we also run ADOT on a EC2 machine or a serverless compute like a Lambda? Is that a possibility?
Definitely, Gaurav. For Lambda, we have Lambda layers. It's a in the configuration which we provide. It's a single click thing where
Mm-hmm.
we can use Lambda layers to run ADOT and export the metrics and traces to uh, services we want. On EC2, also we can run it on EC2 as well.
Mm-hmm.
ADOT. But we would not be running it as a container, but we can definitely run it.
Got it. So I have a couple more questions coming in. So first one is from user D Kumar 707. They're asking, how should I use ADOT for apps that are running on EC2?
So once we deploy the ADOT collector, whether ADOT collector is running in a container or it is running on EC2 machine, what we need to make sure is that the communication between the ADOT collector and application is there. So if
Right.
there are application running and they want to push the traces to ADOT collector, they should be able to communicate to the ADOT collector. Vice versa, if we are using the Prometheus receiver to scrap the metrics, then our ADOT collector should have the capability to connect to application and scrap those metrics. So once it has the metrics and then there is a pipeline, the
Mm-hmm.
pipeline will process that and whatever exporters we have defined in that pipeline, it is going to export those metrics or traces to uh, those services. I
Got
hope
it.
that answers the question.
Yeah, and the exporters, the collector's capability also like to talk to the exporters. So connectivity has to be established from application to the collector and then collector to the target where you want to send the telemetry data.
Yeah.
Right. Yeah, thanks, Arun and Siddharth. Of course, if there are any follow-ups, please feel free to ask them in the chat. I'll move on to the next question that is from Mukul Srivastava. They want to know, do we need to make code changes for open telemetry tracing?
I can take it, Gaurav. So
Yeah.
answer is, code changes, yes and no. So we have basically uh, instrumentation. We have two kind of instrumentation. We have automatic instrumentation and we have manual instrumentation, a part which I think Arun touched upon a little bit, that with automatic instrumentation we have multiple packages, contrib libraries which we can add and we will have instrumentation for our application. So that is either with the low code or no code. So we need to just add the certain packages in our application, define the config, and automatic instrumentation can work for us. Now, how much instrumentation we want to put in our application, depending on that, we may need to write the code as well.
Got it. That makes sense. All right. I think that's everything I had. We'll let you go into the demo now.
So I think we are ready for the demo. So in this demo, uh, what we are going to do is that we will show you the same uh, setup which we showed you in the slides, right? We are going to scrap Kubernetes metrics using Prometheus receiver, and we are going to receive the application traces. In interest of time, we already have set up an EKS cluster of Amazon managed Prometheus workspace and Grafana workspace. We have installed the ADOT operator as well, right? So, but it is very easy to set up ADOT operator on the console. We can go to add-on and then we click on get more add-on. And here we can see AWS Distro for OpenTelemetry. I have already installed it, so I do not see, but if it is not installed, it should be visible there. So once we install it, and if we look at the pods which are running in our EKS cluster, we should be able to see one pod running for our OpenTelemetry operator. So our here is the pod which we can see. It's running on its own namespace, and this is the pod which is responsible for our custom resource definition of OpenTelemetry connector. So here we have the configuration file where we are going to define a resource of type OpenTelemetry collector. And once the Kubernetes API server will receive this, it is going to notify the operator which we have installed, and our operator will read configuration from this file to deploy the ADOT collector. If we look at the configuration, it is the same which we see previously. There are scrap jobs defined for Prometheus receiver, We are going to scrap Kubernetes metrics, and here we have the remote write endpoint of Amazon managed Prometheus service. So on the AMP workspace, if you look, you will find two URLs. One is the remote write and the query URL. So we are going to use remote write URL for exporting our matrices to Amazon managed Prometheus. Later query URL will be used to query it through Grafana. So let's deploy this collector. So once we deploy this collector, it is going to scrape those matrices, process it in the batches, and then push it to Amazon managed Prometheus. So now let's go to Amazon managed Grafana workspace. And in the workspace, we are going to query our Prometheus, Amazon managed Prometheus workspace. But let's first add a data source. So we should be able to create dashboard using the matrices available in the Amazon managed Prometheus. So now we have imported we have created the data source. Let's import a public dashboard which is available for Kubernetes monitoring using Prometheus metrics. So we are going to use this. We are going to specify our Prometheus data source, and once we click on import, we are able to see that our metrics from Prometheus have started coming to our dashboard. This dashboard has a lot of other panels which shows very useful information, and you can also modify these widgets using your own PromQL if you want to do that. So now we have our Kubernetes server monitoring setup. We can look at the setting up tracing for our collecting traces from application and exporting those to AWS X-ray service. So for that purpose, we are going to deploy a sample application first, a traffic generator for that application, and then we will deploy a ADOT collector which receives the AWS X-ray traces and export it to X-ray service. So here we have deployed our traffic generator. Now we are going to deploy a sample application. This application is instrumented using OpenTelemetry SDK, and we have all of this information is available publicly. We will share those links if you are looking to. So we have deployed the application. Now we are going to deploy an ADOT collector. So that ADOT collector is going to receive traces from the application. So this is the endpoint where application is going to push those traces. So we are going to deploy collector with the same name. And I have already configured my file using this name, and we are going to deploy. So once we have deployed the collector, let's look at all the pods which are currently running in our Kubernetes, in our EKS cluster. And we should be able to see the two applications which we have deployed and two collectors which we have deployed, one for the Prometheus one and one for the X-ray. So here all of our 4 ports are visible. Now let's go to AWS X-ray service and check whether we are able to get the traces coming from the sample application which we have deployed. So on X-ray console, on the left pane, we can see the traces. So once we click on traces, we are able to see the traces coming from this application. And to drill down further on a particular trace, if we click on a particular trace, we are able to see all the operations going on with that particular operation. Because it's a very simple application, our service map is also simple, but depends on how complicated your application is and what all activities it is doing. It can be vast, and it can be really helpful for troubleshooting any issues, specifically the performance issues. So with this, I think done with the demo, and I'll hand it over to Arun now.
Hey, thanks, Siddharth, for the demo. So now, as we see the demo, right, and we understand how simple it is to instrument the metrics using ADOT, and especially the ADOT operator for EKS. We understand that how seamlessly we can instrument the metrics and move them to the analysis backend. I also want to highlight that everything that we showed in the demo, there is also an AWS Observability Accelerator. It is a solution which is available for you. If you want to go and automate this entire deployment of AWS managed Prometheus, AWS managed Grafana, and ADOT on EKS, it's completely available as an automated solution. So AWS Observability Accelerator is a set of Terraform modules which allows you to do everything that we did in the demo today and more. So go check out the solution and feel free to use it and share feedback if you have any for this. Once you deploy the solution, as an outcome after you deploy it, you will have certain dashboards which will be available, and it'll be pre-created for you. So you will have different dashboards which will show you different matrices, like let me just okay so like different EKS infrastructure matrices, right? So you will know like how many number of pods are running and other infrastructure metrics which will be streamed from your EKS infrastructure. So all of that will be available. These all will be pre-created dashboards once you deploy the solution. The next thing that I want to highlight is the AWS Observability Workshop. The Observability Workshop essentially is a guide for you, and it's a lab which gives you step-by-step instructions if you want to check out some of the observability service that we have. So if you want to get some hands-on experience with AWS observability services like Amazon Managed Grafana, Amazon Managed Prometheus, CloudWatch, or X-Ray, do check out the lab. It will give you step-by-step instructions and I tell you how you can use different services, and it's a different configuration available in these services. So let's summarize what we learned today. So we talked about the observability, its different pillars, right, and how we can use observability and build and use OTel and building a better observability solution. We also talked about the OTel component and its architecture. We understand now, like as Siddharth also showed, different receivers that we have. So we have different receivers to receive information in different from various sources in different format, right? For example, we have receiver for Prometheus and OTel. Then we also see different processors as you build the pipeline. So you have different processors. When you receive the telemetry signal, you can process that even before you send that to your analysis backend. So you can do batching, you can do filtering, and you can optimize. And you can also add a lot of contextual information before you send the data to the target. And then we have different exporters. So we have different exporters, and depending upon where you want to send the telemetry data. So we have exporter like Prometheus remote write exporter, which allows you to write it to Prometheus. We have CloudWatch exporter, which essentially allows you to write the telemetry signal into CloudWatch. And then we have X-ray exporter, which allows you to send the trace data to AWS X-ray. And then there are different extensions to enhance the overall capability. So we looked at the health check extension, which gives you a health check endpoint to observe and monitor your hotel collector. Then, as Siddharth talked about, we looked at SIGV4 authentication extension, which essentially allows us to configure authentication with different AWS services that we have. And at the end, we also looked at the demo, and we now understand how easy it is. And we talked about the instrumentation, right? So I think there was a few questions around the instrumentation, like how simple it is. Will there be any code change required? Yes or no? So we looked at like how you can use auto instrumentation, which gives you standard set of matrices. But if at all you want to enhance the capability, you can go for manual instrumentation and instrument it for your application, where you will essentially get more rewards when you do it manually. You will have more control what metrics or telemetry signal you want to instrument from your application. Yes, and there are these different links which you see on the screen. So go check out different links. Go check out the observability accelerator solution and the lab that we have. With that, we can break for Q&A, and we also would like to capture your feedback. So please feel free to scan the QR code and share the feedback that you have. that would really help us improve the session for next time.
Right. Thanks, Arun. So I believe we captured all the open questions. If there was any that wasn't, please feel free to let us know, or add your comments in the chat, and we can bring them to the presenters here. I do have one that I believe is open. This was from a user, which we said we'll take it at the end of the show. Um, the question was around X-ray and ADOT and the correlation between that. Siddharth, do you want to take this now? Yeah. So thanks. So the question is there any relationship between ADOT and X-ray? You're on mute, Siddharth.
Sorry, Gaurav. So the ADOT helps is to create those stresses, collect those stresses, process those stresses, and export those stresses. As in Arun mentioned that ADOT is not an analysis backend. X-ray is an analysis backend. So we can export traces to X-ray where we can analyze it. So we can collect using ADOT, but we cannot analyze using ADOT. I hope that clarifies the difference and relationship between these two.
Sure. Thanks, Siddharth. So again, a note for our attendees online: please add your comments in the right hand side of your window to add any questions for the team while we have them here. If you have any questions for our speaker, this is the time to get them addressed.
I
And
think just to
Gaurav,
add to what like the traces, right? The point with hotel collector, you basically will have one collector which can process the trace data and send that to X-ray, as Siddharth mentioned. And the same collector can also receive metric data from different source and move that to a different target, let's say Prometheus. So that really helps a developer to not basically go to different agents or collectors to process different types of data.
and Gaurav, some of the resources which we shared, like the workshop, the observability workshop, and AWS Observability Accelerator, those are really great tools to get
Mhm.
started with this. Right? If someone is looking to get started with this, they'll give them real good hands-on experience, and those are free to use.
Absolutely. So I'm curious, Siddharth and Arun. So because this is an open source, how do new features get requested? Especially talking about AWS distro for OpenTelemetry. What is the mechanism there?
Yeah, so our roadmap is completely available in public, right? So you
Mhm.
can feel free, go ahead, raise your feature request on our GitHub page. And if the feature request is already there, you can vote and you can upvote the feature request. And we'll consider that.
All
And
right.
again, just to add that the contribution will be changes will be done to the upstream. We do not directly make changes to ADOT, right? So we make it upstream and then we take it from there. But you can definitely request for a feature using the GitHub issues on our ADOT collector GitHub repo.
Thank you, guys. So that's all the time we had today. Everyone, today we looked at getting started with OpenTelemetry and ADOT, where Arun and Siddharth walked us through observability, its pillars, using OTel components, and we also had a demo. That we really hope this information was useful, and you would continue to utilize the features and share your feedback with us. If there are any questions that were not answered today, please feel free to post your questions to repost.aws. This is where one of our experts can provide you with an answer to your question, or if needed, it can even become a topic of our future shows as applicable. If you have any feedback for us, please feel free to use the link for our survey, which is in the comment section. You can also send us an email to AWS Supports You at Amazon.com. We really want to hear from you, so do tell us what else would you like to see on this show, what is working, what's not working. We are looking forward to it. Finally, this is our final show for the year 2022. We here at AWS Supports You want to really take this opportunity to thank you all for joining us. We hope to see you again in 2023. We are back on Jan 11th, 10 a.m. IST, discussing AWS Health Aware with ServiceNow integration. So that's our next show. In the final show for this year, again, we would like to thank you for being here with us, and we'll see you in the next year. Happy cloud computing.
Thank you, everyone, and
See you next
I wish you very happy New Year to everyone. Thank you.